Welcome to making a domain-specific language in Python using Snowfakery as an example language. I hope you're enjoying PyCon. My name is Paul Prescod. I'm a performance engineer with SalesForce.org. SalesForce.org is the business unit of Salesforce that's dedicated to working with nonprofits, educational institutions, and philanthropic institutions. We make a variety of products. Some of our tools and products are also open source, so we're also an open source center within Salesforce. This particular tool, Snowfakery, is open source, and it was created based on ideas that were shared with me through a sprint with some of our nonprofit partners. So Snowfakery is actually an example of a collaboration with a nonprofit community. I personally am a longtime Python programmer. You can see in that picture of me that's goes back to probably about 2000, and I was a Python programmer already for a few years then. So I've changed a lot, and Python has changed a lot in the meantime. Today we'll be talking about Snowfakery. Snowfakery is a tool, and it's also a domain-specific language. By domain-specific language, I mean a language similar to a programming language, but specific to some particular problem domain. So just as SQL is specific to the domain of querying relational databases, and Prolog is a logic language, Snowfakery is a language for generating fake data, and the data can have relations between tables. So you can generate complex related data. Key features of Snowfakery is, number one, it's open source. Number two, as I mentioned, it can generate complicated relational data shapes, basically any data shape you can imagine. It can generate synthetic data that looks very realistic, names, addresses, company names, and so forth. In fact, I recently noticed that the data was a little bit too realistic because some systems were accidentally sending emails to real people. So we've dialed back the realism a little bit, but still very realistic from the point of view of demos or performance testing. Snowfakery, as we'll discuss, is very extensible through Python, and it's also data store independent, so it does not need to be used with Salesforce, but it is tightly integrated to Salesforce for those that are Salesforce customers using Cumulus CI, another tool from our suite of tools. Also open source, and also developed in partnership with our open source community. Some of the language design principles that guide the design of Snowfakery. Number one, excuse me, it has to be easy to use. We have this concept in the Salesforce world of a Salesforce admin, so they're not comfortable necessarily with full-on computer programming, but they are quite technical people nevertheless, and so we hope that Snowfakery is within maybe at the edge of their comfort zone, but not beyond it. One of the ways we make Snowfakery accessible is with clear error messages, and I've gone to quite a bit of effort to make them properly localized to a particular line number, and I'll talk more about that later. Snowfakery is extensible using Python, and it's fairly scalable in that you can run it in multiple threads, multiple processes across multiple computers or nodes in a cloud, and if one of them crashes, another one can just pick up. Whether you're generating 1,000 rows, 100,000, or 1,000,000, or even 1,000,000,000 rows in Snowfakery, it should use constant memory usage. There are no data structures that grow with the data size. And Snowfakery is designed to support very diverse use cases, both small and large data sets, both complex and simple data sets, and both data sets that are hard-coded and extremely random. The encoding we use for these is called a Snowfakery recipe, and a single recipe, the same recipe, can support anything from 10 output records to, you could scale that recipe up to 1 billion. So I've already hinted at some of the reasons why we picked Python for this. For sure, because we love Python and we already used it in Cumulus CI. Also because of the powerful libraries and the integrations with things like SalesForce and YAML and SQL and so forth. We get a free expression language, sort of like a spreadsheet formula language, by using Jinja. And we get a free plugin language by using just Python. Some of the core Python libraries that we use, in addition to the standard library, of course, there's PyYAML for parsing YAML, Jinja for what we call a formula language, Click for parsing command lines easily, SQL Alchemy for connecting to SQL databases. Also, through Cumulus CI, we use something called Simple SalesForce, which is a connection to SalesForce for that set of our users that do use Snowfakery and SalesForce together. So now I'd like to give a short tour of Snowfakery, and I think I will do that with a demo. Okay, so now we'll do a quick demo of Snowfakery. Here we have an object representing an account. This could be considered equivalent to a database table or a Salesforce S object, or maybe a JSON object type. And then here we have the name of the account is going to be a fake company name. For each account, we'll generate a fake description. For each account, we'll generate a fake street address and so forth. The number of employees for each one will generate a random number between 0 and 200,000. And for the account number, we'll generate a random number as well. Contact is a similar concept, but instead of a contact being a company, it's an actual individual at the company. So we might generate first name, last name, email, and so forth. Again, these particular objects that I'm referring to are built into SalesForce, but you can literally any schema that you want, you can create the tables for that schema. It does not have to be built into SalesForce. You don't have to use SalesForce at all. You could use Snowfakery just with a relational database or CSV file, as I'll show in a moment. We have birth dates. They're between this particular recipe says the birth dates will be between 20 years and 50 years ago, so that's 30 years. Each of these contacts references the account that was created before. So for every account, I will generate one contact, and I will generate 3 to 5 opportunities using this count feature. I can tell it that I want between 3 and 5 opportunities every time this recipe is iterated. I have a little formula here for the opportunity. The fake word is something that's built in. Will generate and will be interpolated into this string. More date math here, more random numbers, and we also have random choice between 60% chance of picking this, 20% chance of picking that, and so forth. And once again, it's associated with the account number. So I will go back up and I typed this command in before to make it fast, but it's generating 100 accounts into a JSON format, and for every account, it will generate the matching contact and the matching opportunity. So you can think of it as 100 account sets. I can do the same. So we can see in this JSON that some objects are accounts. Just like we described, they would have company names and descriptions, buzzwords, addresses, and so forth. And then we also have contacts. Contacts have names and last names and emails and so forth. The contacts relate to the contacts through the account ID. The contacts relate to the accounts through the contact ID. And the opportunities also relate to the account through the account ID. As you can see, just as I predicted, there would be one contact for each account and between 3 and 5 opportunities. And in this case, I've got exactly 3. I can also generate CSV. And while we're at it, why don't we generate 5,000 of them? So this is generating, again, 5,000 accounts, 5,000 contacts, and between 15 and 25,000, oh, sorry, 15 and 30,000, sorry, that's right, 15 and 25,000 opportunities. So we'll just quickly click on those. Those are the accounts. Those are the contacts. And those are the opportunities. So that's a quick tour of Snowfakery. Here are some other features of Snowfakery. It has macros, which allow you to reuse code in multiple places. So you could define an object type and then have multiple variants of it, or even reuse it across multiple recipes. It has locales, which allow you to take the same Snowfakery recipe and use it in an English locale or a French or Japanese or even UK English versus Canadian English versus American English. It's got conditional similar to a programming language, if, when, else. It has sophisticated randomization, so it's got random numbers just from the standard Python library. It's got random dates from Fakery library. It's got random references between objects, which is a Snowfakery feature. And it's got random choice, which we extend the Python standard library to make that very convenient for Snowfakery authors, recipe authors. Here we have the Snowfakery software architecture. As you can see, it sort of flows from left to right. On the left side, excuse me, we have the, over here, we have the applications that embed Snowfakery, the Snowfakery as a library. So this API is the entry point to the library. Any app can embed Snowfakery. It's open source, so this could be your app. Or you can use the Snowfakery command line, as I showed in the demo. That's one of the apps that embeds it. Or you could use Cumulus CI, which is another app that embeds it and integrates it with SalesForce. Within the library, the API calls the parser, which in turn calls a YAML parser. The YAML parser parses the recipe YAML and generates back lists and dictionaries and strings and numbers and booleans and so forth. And this parser, there's a higher level parser that interprets that in terms of the Snowfakery concepts of things like objects and function calls and field lists and relationships between objects. That in turn feeds the data to the interpreter. The interpreter depends on some other libraries. For example, it depends on Jinja for the formula evaluation. It depends on Faker for the generation of fake synthetic data types. And it calls into the output streams libraries to generate one or more output streams. Example output streams, there's CSV, which we've seen, JSON, which we've seen. We can use Cumulus CI as an output stream to write to salesforce.org, salesforce.org. Or we can use a SQL database through SQL Alchemy. So these are all some examples. We could also even generate an image through GVGen. So that's the overall architecture I'll just zoom back out. Again, you can think of it as the application calling the library reading the recipe, and then generating on the right hand side all of these outputs. Let's talk about output streams. So we've already explored this when we did the little demo. Output streams, essentially internally, they convert write row events, what internally we think of as write row events, write this row, write this row, into bytes on a stream or socket. And therefore they can write to a local file or a set of files like JSON or CSV, or they could write to a remote file or a remote database through a database connection. We can even make vector graphics, as I'll show you in a moment. Basically anything you can imagine you can turn into an output stream. You could connect to different types of data sources or file formats, data storage or file formats. I've got some examples of the coding for output streams. You can click through them at your leisure later, but they, there's an example of a really, just show you really simple. Like I said, you have a write row event, you generate a string, and you output it, and that's about all. The other aspect of it is Snowfakery has the concept of relationships is an important aspect of it, so you need to tell it what how to represent relationships in your output stream as well. Here's a CSV output stream. It's a little bit more complicated because we have different files for each of the CSVs. And here's a JSON output stream, extremely simple. It's just writing out square brackets and JSON data as well. So it's I don't use the JSON library for this because the JSON library is not optimized for streaming, and Snowfakery is optimized for generating millions or even billions of records. So there's an example of JSON. We saw that before. We also saw CSV, how we could generate multiple CSV files. I didn't show you yet that you can generate raw SQL, or you can connect to a database and send the individual insert statements to the database. The list of databases is mostly provided by SQL Alchemy and the Python DB API library. Some of the ones that are supported officially by salesforce.org are Postgres and SQLite, but SQL Alchemy supports just tons and tons of them, and you can see how you connect. You can connect right on the command line, or you could embed Snowfakery in some context in which you pass it an existing database engine connection. Here we use the Cumulus CI command, CCI as it's known, to actually connect to SalesForce org. And CCI will use parallel processing to actually generate multiple bundles or portions of data at once and upload them in separate threads. Snowfakery can use the dot file format, the graphviz DOT file format, to generate simple images, pictures of some recipes. You want to keep the recipes relatively simple and small. I have generated images of recipes with that generate thousands of records, but they're pretty difficult to understand and navigate. We switched from using the PyGraphviz library to the GVGen library, and I would actually advocate everybody use GVGen. PyGraphviz, I found it's a binary dependency that only caused headaches, and GVGen does not need to dynamically link to the Python interpreter at all. Snowfakery has a few different mechanisms, some of which we've already seen for randomized and calculated data. So random choice is select among different things with a particular percentage chance of them happening. There's random number, which is allows you to pick between one number and another randomly. There's a date between, which is similar, but it's for dates, date time between. And then we also have fake data. So fake data is based on this library called Faker, and we've seen this a couple times already. Faker has quite a extensible and comprehensive list of types of fake data. And also, as I said, many of these fake data types are localized to different countries or languages. So, for example, even some countries have different credit card syntax. Of course, many will have different phone number formats and so forth. And Faker has different types of localization built in. So Snowfakery is extremely extensible. The extensibility is based on two concepts, plugins and providers. So plugins are implemented in Python, so a plugin can do any kind of computation or data storage, roughly anything that Python can do. It could call a web service and get new data in, and they add new functions to the Snowfakery language. Providers add new types of fake data in particular, so they are specifically for different types of fake data. So, for example, if you were building a website, a website about clothing sales, and you wanted to be able to fake it, different types of clothing, then you could have a fake data provider for clothing. For our use case, one that we use is nonprofit names. Nonprofit names are a little bit different than company names, and therefore you might want to have fake data for that. Here's an example of a plugin. So at the top we have the YAML. So the YAML, this part is the YAML. And first we declare a plugin, and it looks in a particular package for a particular module and then a particular class within that module. This class will become the name of the plugin. So below I have double this. I'm looking for the class doubling plugin, and I'm looking for a method called double on it, and I'm calling it with an argument of 10. And below you can see the doubling plugin class. It subclasses from Snowfakery plugin. It has an embedded class called functions, which is where it looks for functions, and it has a method called double, and the double takes that one value and then it doubles it. So of course the plugin language is overall more sophisticated than this. It gives you can get access to the current context within the interpretation process. You can get access to other records that have already been created and so forth, but this gives you a sense of how simple they can be. Providers, those are the interface for these is defined by the Faker library, and so Faker says that there will be a class. And the class will inherit from base provider. So here we can see it's inheriting from base provider, and it provides a function called 3-letter acronym. And this just is a little bit of Python code to actually generate a 3-letter acronym. And then up here I use it with the fake keyword. I just say fake 3-letter acronym, and it can find that it was in this particular provider automatically. That's just how Faker works. I'll talk a little bit now about Snowfakery's scalability. When Snowfakery is embedded in Cumulus CI, it uses the multi-processing library to utilize multiple CPUs. So it gets around the limitations of the global interpreter lock for data generation. And then it can use threads or processes to upload the generated data to the server or across multiple HTTP channels. It's actually quite straightforward to call Snowfakery in a subprocess or thread. It's thread safe itself. I've not yet detected any thread safety issues in it. It's very functional in its internal implementation, and every time you call it, it generates a new interpreter object.